These are the notes for lesson 4.4, least common multiple. Now the word multiple kind of sounds like multiply, which is what you do to find multiples of a number. A multiple of a whole number is the product of the number and any non-zero whole number. That means you can't multiply the number by 0, can't multiply the number by a decimal or a fraction. So we need to know the difference between a factor and a multiple, because people often confuse the two. So let's look at factors of 4. Remember, a factor is a number that divides evenly into the number. So the numbers that divide evenly into 4 are 1, 2, and 4. If we want to find multiples of 4, we would take 4 and start multiplying it. So 4 times 1 would be 4, 4 times 2 is 8, 4 times 3 is 12, and it's kind of like we're skip counting by 4s. Okay, notice I put the ellipsis. That means it goes on and on forever. There's actually an infinite number of multiples. Whereas with factors, there's always a finite amount. Okay, so let's jump back down here to our notes. A multiple that is shared by 2 or more numbers is a common multiple. And the least or smallest of the common multiples of 2 or more numbers is the least common multiple. And we abbreviate this as LCM. So let's look at example 1, which is finding the least common multiple. And you're going to find that our steps are very similar to those for finding GCF. Once again, we have two methods. Method 1 says list the multiples of each number, and then identify the least number that's on both lists. So for multiples of 6, we're going to start with 6, and then we're going to count by 6s. So 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. I'll stop there. I'm going to put my dot, dot, dot. My multiples of 10 are 10, 20, 30, 40, 50, 60, and so on. And then if we compare our two lists, we see there's a 30 in both, and there's a 60 in both. So 30 and 60 are both common multiples. Now the ones that's the smallest is 30. So our least common multiple of 6 and 10 is 30. Now when you're doing a question like this by listing, there's not a set number of multiples that you should start with. I would recommend maybe doing 6 or 7 for the first number, and then trying 6 or 7 for the second number and seeing if you have anything in common. And then if not, you can always keep adding a couple more to each list until you find one that works. Now method 2 is to write the prime factorization of each number, just like we did for GCF. So for 6, that would be 2 times 3, and 10 is 2 times 5. And just like before, we're going to circle any common factors we have. We have a pair of 2's, so I'm going to circle them. I'm going to write that down on the side. I'm taking the pair of 2's and I'm just writing it once. Now the difference between GCF and LCM is GCF we would just stop right there. The answer would be 2. For least common multiple, we need to multiply all the factors, which means we need to multiply anything extra that we have. So we had our common 2, but we have an extra 3, and we have an extra 5. And then if we multiply this up, we have 2 times 3 is 6, 6 times 5 is 30. Okay, let's try example 1a, which is finding the least common multiple of 3 numbers, 6, 8, and 20. I'm going to do it the prime factoring way. So 6 would be 2 times 3, 8 would be 2 times 2 times 2. And 20 would be 2 times 10, so I'm going to write down the 2. And then 10 would be 2 times 5. So now just like GCF, you're going to find factors that are common to all three numbers. And here we have a 2 common to all three. So I'm going to circle the 2, write it down on the side. Now the difference here is once you find numbers common to all three, you can also circle numbers that are common to just 2 of your numbers. So here, I have a 2 that's common to the 8 and the 20. So I'm going to circle that and then add it to my list on the side. So once again, circle factors common to all three and then just common to 2. And now we need to add in our extra numbers. So we have an extra 2, we have an extra 3, and we have an extra 5. Now remember, when you're multiplying a bunch of numbers, it's commutative. You can do it in whatever order you want. So if you're trying to do it mentally, you can skip around a little bit to make your life a little bit better. So I have 2 times 2, which is 4. 4 times 2 is 8. I'm going to jump and say 8 times 5 is 40. And 40 times 3 is 120. So the least common multiple of 6, 8, and 20 is 120. Okay, I'd like you to try the 2 checkpoint questions. So at this point, pause the video. If you need help, please look at the examples above and then hit play when you're ready. Okay, to find the LCM of 16 and 24, we're going to prime factor. 16 is 2 times 2 times 2 times 2. And 24 would be 2 times 12. 12 is 2 times 6, and 6 is 2 times 3. So now I'm going to go through and circle common factors. I have a pair of 2's, so I write it on the side. I have another pair of 2's, so I write another 2. I have another pair of 2's. So all my pairs are taken care of. I'm going to write down my extra numbers. I have an extra 2 and an extra 3. So we have 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 3 is 48. Now when you do these, go back and see if your answer makes sense. These numbers here should go into this number here. 16 times 3 equals 48, and 24 times 2 equals 48. So this is a logical answer for these two numbers. Let's do number 2. 15 is 3 times 5. 30 would be 2 times 15, and we just figured out 15 was 3 times 5. And 50 would be 2 times 25, and 25 is 5 times 5. So first we're going to find factors common to all three, and that would be 5. That's the only one common to all three. So now we can go through and find ones common to just 2 of them. I have a common 2, and then I have a common 3. And the only extra number we have is that 5. So 5 times 2 is 10, 10 times 3 is 30, 30 times 5 is 150. Okay, flip your paper over. Example 2, finding the LCM of monomials. We're finding the LCM of 9xy squared and 15x squared y. And our first step is just the same as finding GCF. We're going to factor this out. So we're going to do the number, which is 3 times 3. We have 1x, so times x. And we have 2 y's, so times y times y. For 15, that would be 3 times 5. I have 2 x's, so times x, and then times y. Let's find common factors. I have a 3, I have a common x, and I have a common y. But I have to make sure I put in my extra numbers as well. So I have a 3 and a 5, And I'm just going to write those over here with the other number. I have an extra x and an extra y. So the number part is going to be 3 times 5 is 15. 15 times 3 is 45. I have two x's, so that'd be x squared, x times x, and y times y is y squared. So this is the least common multiple of our two monomials. Okay, pause the video and try checkpoint number 3, and when you're ready, hit play. Okay, we have 6m squared and 10m cubed. 6m squared is going to be 2 times 3 times m times m. And then 10m cubed is 2 times 5 times m times m times m. Well, we have a common 2. Write it down. I have 2 common m's. I have an extra 3, an extra 5, and an extra m. So here, 3 times 5 is 15. 15 times 2 is 30. And then m times m times m is m cubed. Okay. The least common denominator. You've heard this before, right? The least common denominator of two or more fractions is the least common multiple of the denominators. And you'll see this abbreviated as LCD. So for example 3, we're going to compare fractions using the LCD. Okay, you can't compare fractions with different denominators, they need to be the same. So we're going to find one to work with and go from there. So the first step says find the LCD, which means we need to find the least common multiple of 6 and 9. Okay, so on the side, 6 is 2 times 3, and 9 is 3 times 3. Okay, we have a 3 in common. We have an extra 2 and an extra 3. So 3 times 2 is 6, 6 times 3 is 18. And if you can see that right away, you don't have to go through this with the prime factorization to find it. A lot of us might be able to tell right away that 6 and 9 both go into 18, and I'm okay with that. So now we need to write equivalent fractions, which we did yesterday. Okay, we're making the denominator 18 though. So here, if I want to change 5/6 to something over 18, well, we'd have to figure out what times 6 will get me to that 18, and that would be 3. So I'm going to have to multiply my numerator by 3, and that is 15 over 18. Here, 9 times 2 gives me 18, so 7 times 2 gives me 14. So once I have the same denominator, I can then look at the numerator and see which one is bigger. So 15 over 18 or 14 over 18. Well, that means that 5/6 is my bigger fraction. Okay, pause the video. Go ahead and try checkpoint number 4. You're finding an LCD for these two fractions. And then hit play when you're ready. Okay, we need the LCD of 12 and 15. 12 is 2 times 2 times 3. 15 is 3 times 5. We have a common 3. 2 extra 2's and an extra 5. So this would be 3 times 2 is 6. 6 times 2 is 12. 12 times 5 is 60. That's our LCD. So I need to change 7/12 to something over 60. And I need to change 11/15 to something over 60. Well, over here, 12 times 5 gives me 60. So 7 times 5 gives me 35. And on this side, 15 times 4 gives me 60. And 11 times 4 is 44.
So now that I have the same denominator, compare my two numerators. I have 35 and 44. That means 11/15 is going to be the bigger fraction. Last example, ordering fractions and mixed numbers. Okay, my battery's dying, but hopefully we make it through the video. Okay, we're going to first make sure that they all kind of look the same. Right now I have a mixed number and then two improper fractions. So we're going to change this first one to an improper fraction as well. And to do that, we multiply the number times the denominator. 3 times 15 is 45. But then add that numerator in as well. So 45 plus 4 is 49/15. So now I need to find the LCD of 15, 10, and 6. And to save a little bit of time, since my battery is dying, I'm going to go ahead and tell you that the LCD is 30. So I need to change 49/15 to something over 30, 33/10 to something over 30, and 19/6 to something over 30. Well, over here, this would be times 2 and times 2. Let's see, that would be 98. Over here, we'd have times 3. So multiply the numerator by 3, and that would give us 99. And finally, 6 times 5. So 9 times 5 is 45. Carry the 4. 5 times 1 is 5, plus the 4 is 9. Okay, so this would be our smallest. This would be next. And this would be our biggest. So finally, we're going to rewrite them because we don't want to just number them. The first number would be 19/6. The second number, we're going to put it in its original form, 3 and 4/15. And finally, the biggest is 19/6. We made it. My battery's not dead yet, and I am signing off.